Welcome to this demonstration video of the OGC FMSDI Digital Arctic Project Climate Change Scenario, prepared and presented by Gordon Plunkett and Melissa Kang from ESRI Canada. This video demonstrates a climate change impact scenario in the Canadian Arctic region, including the development of a data catalog portal, plus an array of maps generated from disparate web services, including base, climate change, impact, and specialized thematic maps. Challenges included locating useful web services and assessing the data's accuracy, currency, quality, and completeness. The scenario examined alterations due to a shifting climate on coastal dynamics, ecosystems, infrastructures, and residents. To effectively demonstrate these impacts, geospatial data was sourced, accessed, and presented through a series of interactive maps. The architecture for creating these demonstrations was to locate suitable geospatial data using various cataloged and curated data sources, or to publish the data if the web service was not already available, to retrieve the data via standard web-based services, to gauge the data's suitability in terms of accuracy, consistency, and applicability, and then to integrate the data within the catalog or the climate change maps. Typically, standards can help address data format and interoperability issues. However, when it comes to data quality and completeness issues, many sites fall short, making their data unsuitable for this particular application. We developed a methodology and published a website for the discovery and integration of publicly available land and marine geospatial web services for the digital Arctic climate change maps. The various catalog sites contain links to standards-based metadata and web services such as ISO 19139, CSW, WMS, WFS, WMTS, and the ArcGIS REST API. Now, let's have a look at a demonstration of the Arctic Data Discovery application. Here's the FMSDI Data Discovery Portal's English site, and here's the equivalent site in French. These sites adhere to accessibility standards like WCAG, plus are mobile phone and tablet compatible. There are 15 curated sites that are available from government, private sector, and professional groups that permit searching for GIS data for Canadian Arctic climate change applications. Site navigation is available, and selection of a catalog search portal opens the site in a new browser tab. There is also a methodology detailing how a web service can be found and used within the ArcGIS Pro application.
We developed a persistent demonstration portal to provide a series of maps illustrating impacts of climate change on the Canadian Arctic coastline. One challenge of this project is to gather disperse existing and newly published web services across large geographic extent and display them in web maps with good performance for user interaction. These tables show the web services, including OGC standard ones, used in each map. The demonstration site is an ArcGIS online group where users can view a series of maps and applications. The CanCoast publication from the Geological Survey of Canada has predicted sensitivity index of Arctic coastline to climate change, calculated based on many physical factors of the marine coast. The publication has large shapefiles for data layers, but they are not accessible through web visualization. We symbolized it similarly to the CanCoast report. As the layer has more than 1 million segments, it loads slowly when zooming in ArcGIS Pro. To resolve it, we published each layer as a hosted feature layer and a vector tile layer to improve visualization in web maps. The climate change map hosts many ArcGIS REST services published from CanCoast project. The coastal sensitivity layer draws quickly if we zoom into an area with high index. The coastal inhabitant disturbances map illustrates the distribution of communities in the Canadian Arctic. Orange points are First Nation communities. Blue outline polygons and StatCan census subdivisions. The map also has CanVac map service of man-made features. Zoom into Iqaluit Nunavut. We can see residential areas, buildings, and landmarks. The Arctic infrastructure map illustrates coastal infrastructures that are vulnerable to climate change. Zoom into Churchill, Manitoba, we can see a highway, railway, pipeline, and airport. With further zoom in, the map shows a hospital, railway station, some dikes that will all be affected by climate change. This 3D map of Taktayak showcases GIS CanCoast. The level change layer can be extruded by the height of sea level rise to become 3D. It illustrates coastal areas that will be threatened by sea level rise later in this century.
The lessons learned throughout this application development process involved how to discover high-quality internet data sources, how to optimize application performance and scalability, how to coherently visualize disparate data layers, and how to address web service interoperability challenges, including the integration of multi-source, multi-scale, and multi-schema datasets. In this presentation, we have shown the capability to seamlessly incorporate geospatial data catalogs and Canadian Arctic geospatial data into a demonstration platform that is accessible by the public. The demonstrator site is available on ArcGIS Online in the FMSDI 2023 Public Demonstration Group. Our aspiration is that this video, which shows the process, benefits, and challenges of discovering, integrating, and displaying Canadian Arctic geospatial data through interoperable web service standards, will inspire you to explore the integration of geospatial data within your future applications. Thank you for watching this video.